Morning, everyone. Today is day 6 of Math 133, and we are going to cover the Chapter 3 review, and there is a project that goes along with it. Um, so, uh, Next Tuesday, we're going to be covering cumulative review number 1 and the Chapter 4 project. So, next Tuesday is going to be an important one because we're going to have two things going on. We have two today, right? We have a Chapter 3 review and the project, but the project, this Chapter 3 review worksheet, Google Sheet project, is tied to the Chapter 3 review. But anyway, try to come if you're, you know, not sure on which days you can come. Definitely try to come next Tuesday. We have a lot to cover. Okay, but for today, um, so if you click on the Chapter 3 review worksheet, there is a link right here where it says data sets for worksheets at this link, and that brings you here. This document, this Google Sheet has lots of links for all of the data sets for all of the worksheets. So you have to scroll down and find the one you want. We're looking at Chapter 3 review, which is down here. There's two links. One takes you to the Google Sheet, which we're going to have for the project, and the other one takes you to StatCrunch. So I'll drop both links in the chat, but if you're watching this on the video, you'll need to come here and go down to the Chapter 3 review worksheet and click on both of those links. So the Google Sheet one is this one, and so I will drop this in the chat. And we'll do I'll put the StatCrunch one later, but I want to start with the Google Sheet. Okay, so let's go back over here. I don't think I have any announcements, so let's just dive in. The Chapter 3 review is going to start on page 339 in your course pack. Okay. Chapter 3 review, page 339. Okay. It's 4 pages, so go grab those. Um, I've been working through some of the grading. Make sure you take a look at what I've graded. If you submitted the wrong worksheet, you may have gotten marked as a 0, and indicated you need to resubmit that. So pay attention when you're submitting what worksheet you're submitting. So today, Chapter 3 review worksheet is on page 339, and it goes for 4 pages until it gets to page 342. Okay. But at the top of page 339, the following frequency distribution shows the number of athletes for all participating countries in the 2024 Summer Olympics held in Paris. So we have the Winter Olympics coming up. I'm very excited. Summer Olympics, though, we'll talk about this. Um, so we're going to fill in the midpoints, relative frequencies, cumulative relative frequency, just like we've done on other Google Sheet projects in the past. Okay. And so that link I shared in the chat, that'll bring you to this document right here, which is the project for today. Okay. So by doing the project, you do part of the review. So you want to do both. So that's why we're doing both today. Now, uh, I'm going to stop my screen share because I would love for someone else to share their screen and walk us through filling in uh, the information on this Chapter 3 worksheet. Um, so let me stop that. Yeah, there we go. So we're still working on it together, but this time I'm going to have someone else share their day or share their screen for us. Okay. So find out who's brave enough to share their screen. To share your screen, on Zoom, there is a up arrow in a green rectangle. Click on that. Thank you, Caleb. All right, great. So for our midpoint. So first for midpoint, we do a foundational midpoint. So do you remember what we type in for that?
You want me to talk my way through it or
Yeah, that sounds good.
all right. So 100, we're doing the lower limit, so
Hmm.
plus, oh, hold on, let me do parentheses. Sorry. 100 plus 0, divide that by 2.
Yep. Because if you miss those parentheses, it'll just divide the 0 by 2 and you'll get 100 plus 0, which is 100. So yes, what number is right in the middle between 0 and 99? 50 is correct. Good. All right.
And then pretty
Step
much
one.
the same thing on the whole way down.
No, for the other ones, I don't want you to use that same formula.
Okay.
For the other ones, I want you to use the class width. So let's calculate the class width.
Mm,
Do you remember what the formula is for that?
mm,
So
Not off the.
go down to cell maybe like A11, like down below the this table, and what you're going to do equals. Yep, Montez has it for you. It's the lower minus the next lower. So do equals 100 minus 0. Okay. Which
Enter.
when you hit, yep, when you hit enter, that's just going to give you 0 or give you 100, right? 100 minus 0 is
Mhm.
100. So um, the width is how many numbers are in each group. So from 0 to 99, how many numbers is that? It's not 99 because you got to count 0. So 0 is 1, and then 2, 3, 4. And so there are 100 numbers from 0 to 99. So by now that we have that class width, let's go back up to cell B3,
Shall be 3.
and we'll do equals, and we're going to click on the 50 above it, and then do plus 100, plus the width, plus 100. Enter. All right, when you hit enter, you don't need parentheses on this one. You can put
Okay.
parentheses if you like. Adding parentheses usually doesn't mess anything up, but yeah, so what number is directly in the middle between 100 and 199? 150 is the midpoint of that class. So the reason we want to do it that way is because now you can just copy and paste that formula from B3 all the way down for the rest of the empty cells. You don't need to type equals parenthesis lower limit plus the next lower limit divided by 2 equals parenthesis lower limit divided by, yeah, you don't have to keep doing all of those because um, we have a formula now. So I think that makes it easier. So,
Mhm.
right. All right. So those are our midpoints. Okay. Next, we're going to do the relative frequency. And the relative frequency is the frequency divided by the total.
So we
Okay.
need to find the total first.
Sure. So, yep, you can calculate the total first. Okay.
This would be equal.
Hmm.
um,
There you go. 207. Yep.
And then,
So you'll type, yep,
all right, so equals
equals. Yep.
self frequency. So
Hmm.
we're doing 173. And then we want to divide that and actually type in the number, the
Yeah.
total.
So, yep, there is a way that you can do it where you uh, don't have to type in the number. You can use the cell values. So I'll show you that in a little bit, but let's go ahead with just the number. So, yep, divide by 207, and you can copy that down for all of the cells. And we don't need the 1 down at the bottom. You could just delete that. All right. Cumulative frequency is a two-step process. Do
That
you remember
first
the
one was
first
at
step?
153.
Yeah.
That first one
First
was
one is easy,
slightly
right? The
first one, right?
first one is you just
Yep.
copy, yeah, you just copy cell C2. Yep. Um, and then next we can do a formula for cell E3 for all the rest.
So, uh,
It's not yeah, sorry, not sum.
not a sum.
Yeah. You had the rest of it right. So it's equals, and you click the 173 above it. Yep. And then you click the 20 over on the left, and then you hit enter.
Got it.
There you
Okay.
go. That's the one I want. There you go. Now, actually, that sum that you had typed in wasn't really going to mess anything up. Yeah, anyway. Okay, that looks good. And we know that the cumulative frequency is correct if the last one matches our total, which in this case it does. So we are good.
Okay. And
Okay. So, so for cumulative relative frequency, there's two ways you can do it. One way is you take your cumulative frequency divided by the total, which is 207. Okay. We're going to do it a different way this time. Um, can you click on that 173 right there? And let's
mhm,
change that instead of having it as the number 173, let's
mhm.
write it as a formula. Can you do equals C2? Or you can do equals and click cell C2. And then hit enter. So it didn't really it doesn't look like it changed anything, but because it's still a 173. But what it's doing is basically it's saying, okay, go two cells to the left to set wherever C2 is and grab the value that's there. Okay. Now for cumulative relative frequency, the first one will be 0.836, which is two cells to the left, which is cell D2. So what I'm getting at is you don't actually have to do any of this extra work here. So instead, uh, just copy the cells from the cumulative frequency. Just copy them over to the cumulative relative frequency. So just highlight 173 down to 207, highlight all those, and just copy that over here. Yep. And if you hit paste, it doesn't paste the numbers, it pastes the formula. And so if you click on cell F2, you can see that the formula for cell F2 is D2, which is two spaces over, because Google Sheets is smart enough to know when you copy all of your formulas over one cell, it has to change all those cell references to just one cell over. So now what it's doing is it's taking your relative frequencies, grabbing the first one, and then summing up the rest of them. And you can see that the last one is 1.0, which is what it needs to be. And so I find that one much easier to do it that way, but you don't have to. You can do it the way that we talked about a second ago, which is you take your cumulative frequency and divide by 207, because that's your total. Either one of those will give you the same result. So, um, anyway, there's always more than one way to do things. So there's two ways to do it. The last thing we need is we also need a chart. We're going to insert chart for the number of countries. So you need to highlight cells C2 through C7. Those ones are what we want to give the chart on. So insert chart. Nice. Okay. And then, of course, they put it right where we don't want it, right in the middle of everything. So you can shrink it down. That's fine. Move it over to the left or move it, sorry, to the right or below. Either is fine. And this is done. We've finished our project for uh, the Chapter 3 review. So you're going to share that, change your restriction to anyone with the link, and copy the link. And now you'll just submit that in Canvas. Now, you'll need to go to, yeah, modules, and then today is day 6. And what we finished was the Chapter 3 project. So it's the second one. Yep, Chapter 3 review worksheet Google Sheet project.
Okay.
That's the one. And then you'll go down to web URL and just paste that in there. Yep. Submit assignment. You got moons for your confetti. All right. Nice. All right. Thank you, Caleb.
Yeah, no problem. I can
So
stop
you can
sharing now.
Yep, you can stop your screen share. I will take it back over. Um,
All right.
so we went through that pretty quick, but again, we've done this. This is like our third time doing a Google Sheet, one of these projects. But if you missed some of it, I'm going to point out a few things here. So first of all, for the class midpoints, so the formula was you take the previous midpoint, which is this one, 50, and then you add the width, which is 100, right? Um, but what if I wanted to do this again? Like, what if I build this report and I present it to my leader or the CEO or whoever's going to look at it, and they're like, "Oh, this is really great. This is a great report. I want to see this every week or every month, every day." That happens all the time. Usually people will ask me for a report and they'll say they need it like one time, but then once they see it, they're like, this is useful. This is going to be helpful for making informed business decisions. I want to be able to see this more often. Okay. And so if that's the case, your class width might be different if we're looking at a year of data or a month of data or whatever. So I don't want to have to change my formulas every time, because if I type the number 100 here, I'm gonna have to change it every time my class width changes, okay? Instead, if we click on this cell B12 down here, I get 150, but the problem is when I copy this formula down, my formula fails. And that's because, like I said before, Google Sheets is smart. So when you go to the next cell, it tries to move all of your cell references down a cell. Well, there's no class width here. So what you have to do is, if you want to uh, have it where your cell reference doesn't move as you copy, you have to put dollar signs in front of the B and the 12. Okay. So the formula now is B2 plus dollar sign B, dollar sign 12. Okay. Now I didn't put dollar signs around the B2 because that B2 is referencing the 50 right here. And I do want that cell reference to shift down as I copy down. Okay. But the 100 doesn't change. So I'm going to leave that like that. And now when I copy this down, at the very last one, it's still giving me the correct answer because it's looking at B6, which is the midpoint right above it, plus it's looking at B12, which is my class width. So it's adding 100, and it's still giving me the right answer. Okay. Um, so now if I was to rebuild this report and I change my widths and now my widths are 200, um, then that's okay, because uh, this will uh, the formulas are still referencing that. If I had typed 100 into the formula cells or into the formulas, then changing the cell wouldn't change the results. Okay. Same thing with relative frequency. Relative frequency is the frequency divided by the total. And this is for the 2004 Summer Olympics. If I wanted to run this same report for the 2026 Winter Olympics or the 2028 LA Olympics, I'm going to have to change it because the number of countries is possibly going to change. Okay. There's possibly going to be, maybe there's a country that didn't send an athlete to the Winter Olympics, but does for the summer, or vice versa. Okay. So if I just do equals C2 divided by 207, when I redo this report, I'm going to have to redo all my formulas, okay? Unless I use cell references. And so I can't just do cell I can't just do C8 because if I just do C8, when I copy this down, I'm going to get a bunch of divide by zeros because when this shifts down, it's going to, when I copy this formula down, it's now referencing cell C9 and there's nothing there. It's trying to divide by zero instead of divide by 207. So Google Sheets is suggesting you should put dollar signs around your C and your 8. And if you say, yes, I want to do that, then you end up getting the same answer, the same thing that we had before, okay? So it's C2 divided by $C $8, okay? And Elaine pointed out that she and Cindy wrote out instructions step by step. And those instructions might point out like some of those, like how to use cell references differently, as opposed to just copying the number into your formula, okay?
It's the
Anyway,
original way that you did it, not the dollar sign way, but
okay.
it's the
Yeah,
original way.
that's okay. So some of the submissions that people have sent in for other Google Sheet projects did have the dollar signs around it, and so that's probably because I think Alana uses them in her video. So if you watch that video, it'll give you some of that as well. So anyway, this is just some more high level advanced Excel uses. So um, if you already are, an Excel expert, you probably are like, yeah, I already know how to do this. I know what the $2 signs mean. I know what to do when I need $1 sign and not both of them. So technically, we didn't need the dollar sign in front of the C. We could have just done C $8 because the row is what needs to not change. The column doesn't matter. So because we're copying down the same column. So anyway, um, if that's all confusing to you, just do it the way that Caleb did it, where we put the actual number in the formula. It just means that when you redo this report uh, next Olympics, you're going to have to redo all your formulas. Okay. All right. Anyway, let's jump back to what are we doing today? So we did the project. Next, we're going to look at the Chapter 3 review. So that is on page 339 in your course pack. Somehow I lost my focus again. Okay. So even though you already did the Google Sheet project, you do have to go through and fill in all of this, right? So it's 250. So what is this? 0.8. What was it again? 836. All right. So you guys don't want to watch me fill all that in. That's, you already know how to do that. We've already done the Google Sheet project, so I'll let you fill in the rest. Um, let's jump down here to some of these other questions. So just like with all our other worksheets, I'm going to go through twice. The first time I'll go through and uh, give you uh, I'll go through and give you some hints, and then we'll stop the recording. We'll go back through, and we'll finish filling in the rest of the answers. So, shape of the distribution. So, uh, Caleb had it up a second ago, had the chart up. Um, is it skew left, skew right, or symmetric? It is skewed right, yes. We have a huge bar for the first one, 173, and then the rest of them tail off. Okay. Number of athletes for a country, is that qualitative, quantitative discrete, or quantitative continuous? Montez says it is discrete. Yes. Um, so can you have, so we said that discrete in this class, we say that it's can you have decimals? Okay. Can you have half an athlete? Um, so yeah, it's not I'm not going to make a Paralympics joke, half an athlete. So, um, all right. Uh, let's skip this one. So, The value for E is an example of a parameter or statistics. So Rachel says it is a parameter. I agree, because are we looking at a population or a sample? Well, when we see the word all, that means that we are looking at a population, okay? So this is looking at all the countries. All right, so down here for question I, find the mean and the unadjusted standard deviation. All right, so mean and unadjusted standard deviation for this frequency distribution. There are three methods that we're going to talk about in this class to calculate mean and standard deviation, okay? So which method is this? So let me pull up, let me grab which page. Oh my goodness, I don't have it in front of me. Here it is. All right, so in your course pack, you have an exam notes packet. And yours is going to be yellow. Unfortunately, mine is not on a nice yellow fun page, but that's okay. So mine is on page 231. Can somebody verify that I have the right starting page for that? I taught this class last semester and we changed it to 253, says Elaine. All right, well, that means I have an old course pack in front of me. That's no good.
Sorry.
No, that's okay. 253. There we go. All right, so the exam notes packet, though, you'll be able to use this on test day. You'll be able to have this in front of you, okay? So, you know, there are a lot of things to talk about in this class, and there's formulas and stuff like that. This is not a memorization class, and math itself should never be just rote memorization, okay? Math is about learning how to solve problems, and there are times where there's some formula out there, but you don't need to have it memorized, right? You can look things up, you can Google it. There's lots of tools out there. The key is knowing how to use them, okay? So you have this exam notes packet that you are allowed to have with you on test day. That doesn't mean you will just have the answer in front of you. You'll have the tools in front of you to solve these problems, okay? So you do still need to know how to do them. So page 254, though, at the top, we have, yes, and you are allowed to write on it. I know that it says do not write on this packet. That's for other classes. I'm allowing you to write on it. And the other thing is, Montez, like, can you write on this? You are allowed to write on this because you're allowed to have a 8.5 by 11 piece of paper with you as well on test day. So, you can just write what you write on that right here. So, yeah, if you need, you know, you can write on on here, right? Good luck on your test, right? Give yourself a pep talk, okay? So, okay, page 254 at the top, there are three methods for finding mean and standard deviation, okay? Now, mean is easy to do. Mean is you add up the numbers and divide by how many numbers there are, okay? You've probably done that before. Mean is finding an average, okay? Whenever we talk about mean in this class, we will be talking about average. And whenever I ask you to interpret things, we'll probably use the word average. But don't tell a statistician that they're average. Don't ever tell a statistician that they're average. It's mean. Sorry, it's a dumb dad joke. Um, so mean and average are interchangeable. And like I said before, we're going to be doing a lot with mean and standard deviation, especially after the midterm. But I'm not going to require you to calculate a standard deviation. There is a formula for it, and it's not that complicated. Basically, a standard deviation is the mean distance away from the mean, Okay, it's the average distance away from the mean. So you basically calculate your mean and then check all your data points against that and figure out how far away they are and then take the average of that. Okay. It's not technically what it is, but that's the best way to think about it. Okay. But it does take a while to calculate, and so we're not going to do it ourselves. Instead, we're going to use StatCrunch to calculate all of our standard deviations for us. Okay. Now, there's three methods. The first is if you have raw data, and that is a single column of data. Next is a frequency distribution. Okay. And last is if you have a probability distribution. We'll use this when we get to chapters 5 and 6. Okay. But for now, in this case, I have a frequency distribution. So I will be using method 2 on page 254. Okay. All right. All right, so I'm not going to do that right now. I'll show you how to do that in just a second, but keep that in mind. Also, by the way, down here, we need to interpret. Whenever we see the word interpret in our class, that means we need to write a sentence. Okay, so explain what that means. There is a script for that. That script is on page 253, and it's the give or take script. Okay, it's at the top. We expect that the data to be mean, don't forget your units, give or take, standard deviation. Don't forget your units, okay? Next page is page 340, okay? Okay, so the following shows the per capita energy usage or a random sample of countries in the world. And it's asking us to find lots of things. X bar is the mean, okay? It's the sample mean, okay? Sample size, minimum, quartile 1, median, quartile. Yeah, it's asking us to find lots of stuff. Okay. One of them is this one, S. S is the sample standard deviation. Okay. And again, like I said, we're not going to calculate standard deviations in the class. We're going to have StatCrunch do it for us. Okay. So again, page 254. But this time, should I be using method 2? No, I don't want to use method 2. Method 2 is if I have a frequency distribution. That's not what I have here. I have a single column of data. I have a bunch of numbers. Okay. So I want to use method 1. Okay. Now, this, what we're doing in StatCrunch, do I have to enter all of these numbers into StatCrunch? I mean, there's not that many, but typing them out could take, a little bit of time. Okay, so that's where this second link comes in. So on the chapter 3 review worksheet, there's a link here for StatCrunch, and when you click on it, it brings you here, and this is exactly that same column that we were looking at a second ago. It's energy usage. It's the energy usage rate. Okay, so make sure you sign in or register, enter your username and password, and then you'll be able to do method 1 for StatCrunch. Okay, so for all of this data. All right. Energy consumption is qualitative, discrete, or continuous. Energy consumption is which of these? What do you guys think? Is that, yeah, so we're going to say that it is continuous. Thank you, Rachel, because energy usage can have decimals, right? And you can see that right here. We have decimals, okay? All right. When you see the word interpret again, that means you're going to write a sentence, okay? This one right here, interpret the mean and the standard deviation in the context of the situation. There is a script for that on page 253. That's the give or take script that we just talked about. Okay. This one, there is a script for that as well on page 253. And that is the percentile script, okay? A script for interpreting percentiles. Okay. Lower fence and upper fence. There's a formula for those. That formula is not in your exam notes packet, partly because we think that it's a pretty easy formula to remember. But like I said before, this is not a memorization class. This is a understanding what the formula means and being able to interpret it. Okay. So if you need the formula, the lower fence formula is you take quartile 1 and subtract 1.5 times the interquartile range. Okay. You could just do that in the calculator. Okay. But if this is a formula that you're going to have a hard time memorizing, feel free to write it on your 8.5 by 11 piece of paper. Because you can write whatever you want, 8.5 and 11 by 11 piece of paper, front and back for test day. The upper fence is very similar, except instead of Q1, we use Q3, and instead of a minus, we do a plus times interquartile range. Okay. So this is not the answer, by the way. This is just the formula. So you have to actually give me a number. Okay. Next page is page 341. And we're still using the same data from the energy usage, okay? So continuing on, this distribution appears to be skewed left, so we'll come back to that. What are the best measures of center and spread for this data? There's two possible answers. I'm going to underline them, but one of them is the correct answer, one of them is not, okay? So this one is definitely wrong. This one is definitely wrong, okay? Two possible answers are mean and standard deviation, and you use this if the previous answer was symmetric, okay? Because mean and standard deviation have more statistical power. That would be the answer here, more statistical power. If the data is skewed, you should be using median and interquartile range because they are resistant to skewing, okay? Median and interquartile range are definitely something that, even though we don't hear, we usually talk about averages. Averages come up a lot in conversation, but median and interquartile range are usually much better when you're talking about skewed data, okay? India in 2025 had a per capita energy usage rate of 1.36 per person. What is India's Z-score? Okay. Formula for Z-score is on page 253, and it is right here, okay? Now there's three of them. Z equals the value minus the mean divided by the standard deviation. Population, it's X minus mu divided by sigma. What does that mean? And then for samples, it is X minus X bar divided by S, okay? Don't let all this confuse you. They are all one formula, okay? You take the number, in this case, the number that we're looking at is India. India's 1.36. You subtract the mean, whether it's a sample mean or population mean, that doesn't matter. Okay, you subtract the mean, put it in parentheses, and divide by the standard deviation. Again, it doesn't matter whether it's sigma or S, you're going to divide by the standard deviation. Okay, so Z equals, and my Z's always look like 2's, so I have to put a line through the middle to make it look like a Z. It's the value minus the mean divided by standard deviation. Okay. Now, where do you get the mean and the standard deviation? Well, you just calculated them. That was back over here, right? Okay. Now, your z-score could be positive, it could be negative, okay? It may be small or it may be very large, okay? So is India unusual? Okay. So we consider something to be unusual if the probability is less than 5%. Okay. Now, that's if we're using probabilities. Okay. Every z-score has a probability associated with it, and every probability has a corresponding z-score. Okay. Um, so you need to pay attention when you're talking about whether something is unusual or not, whether we're looking at z-scores, which is the number of standard deviations away, or if we're looking at probability. Okay, we'll see that throughout the class when we're talking about if something is unusual. Okay, we consider something unusual if something has less than a 5% chance of happening, right? Like if there's, let's say there's an event that's happens rarely. Like let's say, you get in your car and you drive to work and you get in a crash. Okay. Does that happen all the time? No. You probably get in a crash maybe, you know, uh, less than 1% of the time, right? Yeah. So that's a rare thing. Now, if that's happening to you all the time, then there's a different problem, right? Um, so something is unusual if it happens less than 5% of the time. Now, for z-scores, a z-score is how far away you are from the mean. Okay. So this would be 1, 2, 3 standard deviations away. For z-scores, 5%, this is 95%. So 5% is the opposite of this 95. And that goes along with the 2 standard deviations. So basically, we say that something is unusual if your z-score is bigger than 2 or your z-score is less than -2. Okay. So you're going to calculate your z-value. You're going to calculate your number here. Whatever number it gives you, you're going to check, is that number bigger than 2? Is that number less than -2? Okay. If it's not, if your z-value is, it's not unusual. It's not unusual to be loved. All right, here we go. If your z-score is between 2 and -2, then it is not unusual. Okay. Now, we're going to play pretty fast and loose with less than or equal. Okay. Um, what if it's exactly equal to 2? I'm not going to worry about that. That's never going to happen. Okay. Uh, if it does happen, then we'll say that, okay, maybe it's usual or unusual. I don't care. Okay. And this is kind of going to be true throughout the class that we're not going to really pay too much attention to whether you're using greater than or greater than or equal to. Okay. But there you go. All right, let's move on. Question number 3. Birth rate of babies in the US is normally distributed with a mean of 7.48 and a standard deviation of 1.23. Construct an accurate normal distribution with the parameter and percentages labeled below. Okay. You'll find the labels that you need on page 253. Okay. So right here in the middle, this is the mean. It's also the median, and it's also the mode. When you have a normally distributed, very symmetric distribution, the mean, median, mode are all 3 the same number. Okay. It's only when things are skewed that, we say, oh, well, the median's a better choice. Okay. So this right here, we're going to write 7.48 because they say that's the median. Okay, so right here, or sorry, the mean. So this mu is the population mean. Okay, so we're going to put that right there. We're also going to go up by 1 standard deviation. So we're going to add 1 standard deviation. And in between those two will be 34%. Okay. So by going up by 1, so 7.48 pounds, that's a normal baby weight. Okay. If we add 1.23, that's our standard deviation. Now we're going to be at what? We're going to be at 8.71, correct? 7.48 plus 1.23. Put those in your calculator. You should get 8.71, okay? And there's 34% of babies are somewhere in this range between 7.48 and 8.71, okay? We'll also subtract 1 standard deviation, and that'll also be 34% this way. So when I subtract 1.23, I get 6.25, okay? So in between these two is a total of 68. 34 plus 34 is 68. And that's what this is saying right here. Approximately 68% of the data lies within 1 standard deviation of the mean. When we talk about z-scores, that's what we are talking about is how many standard deviations are you away from the middle, okay? So if I had a baby that weighed 6.25 pounds, that would be exactly 1 standard deviation away from a normal average, okay? And you're going to keep going. You add 1.23 again, so 9.94, and add 1.23 again, you get 11.17, okay? And subtract 1.23, so that is 5.02, and then one more time, we should get, somebody do 5.02 minus 1.23 for me. Thank you, Caleb. 3.79. So all of these percents are just the numbers, are just the percents here, okay? We're just filling in for 3 standard deviations, okay? Now, is there more past this? Yes, there is. This technically, this line goes on forever, okay? Same thing over here, okay? So you could look at 4 standard deviations, 5 standard deviations, 6 standard deviations away, okay? But at that point, the percents are so small that it's going to be hard to write them, and they're going to be tiny, okay? So we're going to stop at 3 standard deviations. That's probably good enough, okay? Now down here, the question is, would it be unusual for a baby to weigh 9 pounds? Okay, so 9 pounds is right here. It's in between 8.71 and 9.94. Okay, is it unusual for a baby to weigh 9 pounds? Okay, so we need to know if we need to know this baby's z-score, right? We said that it's unusual if their z-score is bigger than 2 or less than -2. It's not unusual if it's between 2 and -2, okay? And the reason why is because outside of those 2 and -2 is all of this dark shaded region. So this area here and this area here adds up to a total of 5%. And we said earlier that when you're looking at probabilities, it's if it's less than 5%, okay? Last page, and then we'll go back through. So page 342. this box plot shows the payrolls for all major sports teams in the US in 2025. Okay. Which sport had the highest average? Now, normally when we talk about average, we mean mean, but box plots don't include the mean. They include median, okay? So it's fine. We can use median here, okay? So the median is the middle line, okay? So this median right here is at what, at like, I don't know, $75 million. This median here is at like, 145, okay? So which of these sports has their middle line farthest along the x-axis? That's a question for you guys. What do you think for question A? Which sport had the highest average? NBA, yep. NBA's middle line is right here. Its median is somewhere around like 170. Okay. Okay. Which sport had the lowest range? Lowest range is minimum to the maximum. So it's asking you which one has the widest total. So that would be MLB, right? Looks like the NHL range is very small. It's this distance, okay? Which sport had the largest spread, IQR, interquartile range? That's asking for the size of the box. Which of these has the biggest box? Also MLB. Thank you, Nicole. Okay. All right. I'm gonna skip through some of these. Let's do G and then we'll stop the recording. So Kansas City Chiefs had the highest NFL payroll of what? Make sure you give units. So Kansas City Chiefs are NFL. So they said that that is the highest payroll. So how would I measure that? What number is this for part G? $220 question mark. Yes, you got it. 220. So NFL's here, and the five numbers in the five number summary are the minimum, quartile 1, the median, quartile 3, and the maximum. They said that the Kansas City Chiefs had the maximum, so here's the maximum right here. This line represents the highest paid NFL team, and it's right on the 220 line. So don't forget to include units, so $220 million. Okay. Good. Okay. All right. Let's pause the recording and we'll go back and we'll fill in the rest of our answers. Okay.